Um, Let us start with our lecture number 40, time, speed, and distance. Okay, so time, speed, and distance. So in this, our concept, let us start with concept of acceleration. Now, acceleration is defined as the rate of change of a speed. Okay. Now, acceleration can be positive, that is, speed increases, or negative, that is, speed decreases, also known as deceleration. Okay. So, acceleration can be positive or negative. Fine. Now, see, this is a very simple concept. We only have to know that final speed is equals to initial speed plus acceleration into time. So basically, whatever be the acceleration, when you multiply that by time, you will get the amount by which your speed will increase relative to initial speed. Okay, so this is the concept of acceleration. We don't get too many questions related to acceleration, but just to revise the formula, we are seeing it because when we are reading time, distance, and speed, we must know about acceleration. Okay, so fine. I think everybody must be already familiar with this thing that final speed is equals to initial speed plus acceleration into time. If we see a simple question related to this, so for a body, for example, if a body has initial speed of 5 meter per second and deceleration it is given as 0.1 meter per second square, it will take 50 seconds to come to rest. Okay, so see, 5 meter per second is the initial speed. Okay, now to come to rest, final speed is equals to 0, and you know final speed is equals to initial speed minus acceleration into time. Okay, sorry, minus deceleration into time, because this is deceleration, so we have to subtract it. Okay, so we have this initial speed as 5 meter per second. What is deceleration? This is 0.1 meter per second square into time, which is 50 seconds. Okay, so this becomes 0.1 into 5, you get 5 meter per second. Okay, so this becomes 0. Okay, this becomes 0, so this becomes equals to 0, final speed becomes equals to 0. So this is how we do these question. Now let us move on to the next question. uh, Okay, fine. Now look at this question. What this question is saying: water flows into a cylindrical beaker at a constant rate. The base area of the beaker is 24 centimeter square. The water level rises by 10 centimeter every second. How quickly will the water level rise in a beaker with a base area of 30 centimeter square? Okay. Now see what the question is saying, that there is a cylindrical beaker. Okay, and in though that cylindrical beaker, water is flowing into a constant rate. The base of the beaker is 24 centimeter square. So area of the base of the beaker is 24 centimeter square. The water level rises by 10 centimeter every second. Okay, so 10 centimeter every second the water level rises. How quickly will the water level rise in a beaker with base area of 30 centimeter square? So actually 24 centimeter square is the surface area, and 10 centimeter square 10 centimeter is the height. So actually 240 centimeter cube is the volume of water that is coming per second into the beaker. 240 centimeter cube is the volume of water that is coming that is coming every second into the beaker. So now the question is asking how quickly will water level rise in a beaker with a base area of 30 centimeter square. So in 1 second, when the base area was 24, so you get 240 centimeter cube. Okay. Now you know that the water is flowing into the beaker at the speed of 240 centimeter cube. Okay, centimeter cube per second. Okay, now the base area is 30 centimeter square. So let us just divide this by the surface area, so it will give height. So you get your height is equals to 8 centimeter per second. So every second the water level in the beaker will rise 8 centimeter when the beaker has 30 centimeter square base surface area. Okay, when the beaker has 30 centimeters square base surface area. Okay, fine. So this is how we do these kind of question. Now let us move forward to the next kind of the question. Okay. Now see, look at this question. It is saying a 2 kilowatt heater can boil a given amount of water in 10 minutes. How long will it take a less powerful heater of 1.2 kilowatt to boil the same amount of water? Okay, so it is saying that a 2 kilowatt heater is there, and it is doing what? It is boiling the given amount of water in 10 minutes. Okay, boiling the given amount of water in 10 minutes. So actually 2 kilowatt energy, okay, 2 kilowatt energy is given for 20 minutes. Sorry, 10 minutes. Okay, fine. So we need 20 kilowatt minute of energy. Okay, 2 kilowatt energy is given for 20 minutes. So 20 kilowatt minute of energy we need. Okay, to boil that given amount of water. Now this less powerful heater is only giving 1.2 kilowatt. Okay, so how long will it take, it is asking. So we need to calculate the time. So how we will calculate the time? We need 20 kilowatt of energy the per minute. Okay, we need 20 kilowatt energy minute. Okay, and this is giving only 1.2 kilowatt energy. So just divide this by that. So 20 divided by 1.2, how much you will get? 200 by 12. Okay, 200 by 12, this is 100, and this is 6, and this is 50, and this is 3. Okay, so this will come to be how much? 50. So this is 3 one times. Okay, this is 3 6 are 18. Okay, and this is 3 6 are 18. So 16.66. Okay, 16.66 minutes. Okay, so a less powerful heater will give your energy 16.66 minute. Okay, so this is how we do these kind of questions. Now, look at this question. A less powerful heater of 1.2 kilowatt, a less powerful heater of 1.2 kilowatt to boil the double amount of water. Okay, now the amount of water is doubled. Okay, now the amount of water is doubled. So energy required will also be doubled. So earlier you need 20 kilowatt minute to boil your water. Okay, earlier you needed 20 kilowatt minute to boil your water. Now you need, because the amount of the water is double, now you need 40 kilowatt minute to boil your water. Okay, now you need 40 kilowatt minute to boil your water. So 40 kilowatt minute divided by 1.2, how much are you getting? 20. Okay, or you can do this 400 by 12. Okay, now this will be just the double the amount in minutes. Okay, just double the amount in minutes. So this will become what? This will become 200, this will become 6, this will become 100, this will become 3, and this will become 33.33. Okay, 33.33 minutes you will need. So this is how we do this question. See what we did actually in this question. 2 kilowatt energy heater. So this is giving 2 kilowatt energy for how many minutes? 10 minutes. So total we need 20 kilowatt minute of energy. Okay, to boil a certain amount of water. Now it is saying this a less powerful heater we are using. So we need 20 kilowatt minute energy. This less powerful heater will take longer time to heat water. Okay. So this less powerful heater will take longer time to heat water. So you could have done this in this way also. Like what? Heat H1 by H2 is it, and because this will take longer time. Okay, so that is equals to T2 by T1. Okay, this will take longer time, so that means it is inversely proportional. Okay, because heat required to boil the water is equals to heat into time. So you know, when this heat is constant, then this heat and time are inversely proportional. Okay, this heat and time are inversely proportional, so you can use this method also. So H1 by H2 is equals to T2 by T1. Now what is H1 here? 2 kilowatt. What is H2 here? 1.2 kilowatt. What is T2 here? We need to find it out. Okay, what is T1 here? That is 10. Okay, so you get 2 into 10 divided by 1.2. Okay, so this is also a method because this is inversely proportional. See, always make your equation and try to determine the relationship between them. What thing is constant? How can you like break down the equation? How can you take the variation? How can you convert that into proportion? Okay, so these kinds of things are necessary in doing these kinds of questions. So I hope everybody understand this. And similarly in this question, now see what is there, a less powerful heater of 1.2 kilowatt to boil the double amount of water. Okay, So now, obviously, to boil the double amount of water, now water is increased. So that means, see, when the amount of water is increased, then heat will also increase. So the amount of energy needed will become just double, 20 into 2. So you have 40 kilowatt. So now H1 by H2 is equals to T2 by T1. Okay. Now what is H1? 20. What is H2? 40. What is T2? T2 is 1.2, and what is T1? That is 2. Okay. Sorry, we need time. Okay. So we need time here. Okay. So sorry. So what here, H1 by H2 is equals to T1 by T2. Okay. Now earlier when were having how much, earlier we wanted to calculate 20 kilowatt, and then now we want 40 kilowatt. Okay. Earlier our heater was giving 2 kilowatt. Now it is giving 1.2 kilowatt. So here we don't need this equation. We don't need the proportion equation. We just need to calculate that how much time it will take for 1.2 kilowatt to give 40 kilowatt minute of energy. Okay. How much time it will take? So we get this as 33.33. Okay. How much time? 33.33. So this is how you do these kind of question. I hope everybody is clear with this thing. Now let's move forward. See, now sometimes we have to find average speed in the question. So earlier, if you remember, we got a formula 2s1 s2 divided by s1 plus s2. So this is the way we can form average speed if two speeds are given. But there is method of alligation also to find the average speed. So the average by the method of alligation. Okay, how to calculate the method, how to calculate the average by the method of alligation. Okay, so let us start. Okay, so see, 60 kilometer per, the question is saying our car travels 60 kilometer per hour from Mumbai to Pune at 120 kilometer per hour from Pune to Mumbai. What is the average speed of the car for the entire journey? Okay, what is the average speed of the car for entire journey? So 60 kilometer per hour from Mumbai to Pune, and 120 kilometer per hour from Pune to Mumbai. Okay, so what is the average speed of the car for entire journey? So let us understand how we can do this question by the method of allocation. Okay, so at one end you have 60 kilometer per hour, at 100, at another end you have 120 kilometer per hour. The distance traveled is the same in both the cases. Okay, now let us calculate the ratio of the speed. The ratio of the speed is 1 is to 2. Okay, the ratio of the speed is 1 is to 2. Okay, so when we will calculate, the value of the time will be how much? Okay, so see, if the ratio of the speed is S1 by S2 is 1 by 2, so the ratio of T2 by T1 is how much? 2 is to 1. Because if you are traveling at 60 kilometer per hour, then you will take twice the time. So we will write 2 here. Okay, we will write 2 here, and we will write 1 here. Understand this thing. When the ratio came 1 is to 2, why I wrote the when the ratio came 1 is to 2, when the ratio of speed came 1 is to 2, still I wrote that time that here 2 is to 1 will be the ratio. Why? Because see, your speed is less, you will take more time. है ना? So weighted average when we are doing, because allegation is what? Weighted average only. We already studied allegation very well. So allegation is weighted average. Okay, so that is why I wrote here 2 is to 1. Okay, why? Because at speed 60 we will travel twice the time. Okay, we will travel twice the time. Okay, now fine. Okay, so see, so now we got that what, when we'll write 60 here, we'll write 120 here, we'll write 2 here, we'll write 1 here. Okay, now what is the average? Okay, what is the average? So how we will calculate the average? See, this 1 corresponds to this because this has come one part here because of this 60, and this 2 corresponds to this 120 because this has come two parts here. Why? Because of this 120. Now what is the difference here? See, 120 minus 60 is equals to 60. So how many parts are there? 20. We have three parts of 20 each. Okay. But the average here will be how much? 80. Why? Because this 60 is trying to pull towards itself. Okay. This 60 is trying to pull its average toward itself. Okay. By how much? By one part. By one part. Okay. So you will get this. And this, because this two correspond to this, so it is trying to pull average toward itself, but it is two parts short. Okay, so I hope you understand. We have already done allocation. This is not very difficult for us. See what is happening here. I wrote here 60, I wrote here 120, I wrote here 2, I wrote here 1. Why? Because weighted average time here is more. Okay, time here is more when you are traveling with less speed. Okay, so whenever you are traveling with less speed, you are taking more time. Now we have this as what? We have this as 60. The difference is 60. When you divide this by 2 plus 1, that is 3, you get 20. Okay, you get 20. But this 60 will correspond to this one. So just add plus 20, right? 80 here, or you could have subtracted 40 from 60, sorry, 40 from 120, so then you could have got 80 here. Okay, so I hope you understood how to calculate the average speed. Now let us look at the next question. Okay, so understand this thing. If the car goes from 100 kilometer goes 100 kilometer at a speed of 66 kilometer per hour, and 200 kilometer at a speed of 110 kilometer per hour, what will be the average speed? Okay, what will be the average speed? Fine. So let us do this thing. Now what is the ratio of the speed? 66 by 110. Your S1 by S2 is 6 by 10 or 3 by 5. Okay. So when the ratio of the speed is S1 by S2 is 3 by 5, the ratio of the time T will be how much? T1 by T2 will be 5 by 3. Okay. So the ratio of time will be 5 by 3. So write 66 at one end, write 110 at another end. Now the ratio of time is 5 and 3. Okay, why? Because this is the lesser speed, so we will travel more time. We will take more time when we are traveling with lesser speed. Okay, so now let us calculate what is the average speed. Now 110 divided by 110 subtracted by 66, how much you are getting? 44 you are getting. Okay, 44 you are getting. Fine. Now 44, divide this 44 into 8 parts, because 5 and 3. Okay, divide this 44 into 8 parts. Okay, so what you are getting here is basically 22, not 22, you'll get 11 by 2. Okay, you'll get 11 by 2 because 4 11 times and 4 2 times. So you will have 5.5. Fine, you will have 5.5. Now multiply this by 3. So you will have this as 15, 1, and you will have this 16.5. Okay, you will have this 16.5. Add this 16.5 into 60 into this. Okay, so you will have this as 12 and you will have 82.5. Okay, so you will get 82.5 average. Now this is wrong. Okay, this is wrong. I'll tell you why this is wrong. Okay, I'll tell you why this is wrong. See, you could have got 82.5. This is 16.5. Just add this 16.5 here. Will get 82.5. Or you can do what? Just 5.5 into 5. So this is how much? 5 fives are 25 to carry over. 5 fives are 25, and this is 27.5. Just subtract 100 and this from this, so you will get 5, you will get 2 here, and you will get how much? This will become 10. Okay, this will become 10. Okay, because this one only we are borrowing. So we are getting 82.5. So answer is not wrong because we are wrong in calculation. Okay, there is no problem like that. The problem is we forgot one thing. Okay, we forgot that we did not take 100 kilometer and 200 kilometer. Okay, our average, if you want to check by our linear method, So that will come how much? See, average speed is equal to what? Nothing but distance divided by time. What is distance traveled here? 100 kilometer by 66 kilometer per hour and 200 kilometer by 110 kilometer per hour. So the our distance is 100 plus 200. Okay. Now this time is how much? 100 divided by 66. Okay. And this time is how much? 200 divided by 110. Okay, 200 divided by 110. Now this is 300 divided by, this is what? This is 660. Okay, this is 660. Multiply 10 here, you will get 1000. Multiply 6 here, you will get 1200. Okay, so this will be 300 divided by 2200 into 660. Okay, just cancel this and this and this and this. So your speed comes to be, average speed comes to be 90 kilometer per hour. Okay, average speed comes to be 90 kilometer per hour. But are you getting that average speed here? No. Okay, you are not getting that average speed here. So let us see how we can calculate the average speed here. Okay, let us see how we can calculate average speed here. See, take the perspective of distance as well. Okay, so 100 kilometer is traveled by 66 kilometer per hour and 200 kilometer is traveled by 110 kilometer per hour. Okay, so we have to look at all the perspective. Distance here, the ratio of distance is 1 is to 2 and the ratio of time here is how much? See, the ratio of time here is 66 divided by 1 by 110, that is 6 by 3. Sorry, that is 6 by 10 or 3 by 5, and this becomes 5 is to 3. Okay, this becomes 5 is to 3. So now let us calculate this. Okay, so you have this 100, you have this you have this 66. Okay, so you have this 66 here, okay, and you have this 110 here, okay, but at 66 kilometer per hour, we are traveling 100 kilometers, so the ratio is 1 is to 2. So multiply this. So multiply this ratio 5 is to 3 and 1 is to 2, you will get 5 is to 6. Okay, you will get 5 is to 6. Now the ratio becomes 5 is to 6. What is the difference here? 44. Divide 44 by 5 plus 6, so that becomes 11. So 44 by 11, so that becomes 4. Okay, now what you will do, this 6 corresponds to this 66 and this 5 corresponds to this 110. Okay, so you can do what? 6 into 4 is 24. Okay, just add this into 66. So 0 and this one becomes 90. Okay, so 90 is your average. That was the actual average that we calculated. Okay, that was the actual average that we calculated. So now you have what? You have 110. Even if you can do by this method also. Okay, so 5 into 4 is 20, and when you subtract 110 minus 20, you will get 90. Okay, now see, this alligation method is very simple. Okay, see how this alligation method is simple of calculating average speed. Okay, so you are given distance ratio 100 and 200. Okay, by speed you can calculate the time ratio. Okay, 66 by 110, that means 6 by 10, that means 3 by 5, that means 5 by 3. Okay, so now you have this ratio of 1 is to 2 and 5 is to 3. Okay, so the ratio becomes 5 is to 6. Now put your speed here, 66 and 110, put 5 here, put 6 here, and calculate the difference here. You get 44. Okay, divide this by 5 plus 6, so you get 4. You have 11 parts of 4 each. Okay, and this corresponds to this. So 6 into 4 is 24. Just add 24 here and you will get your average 90. So this is very simple, instead of going 100 plus 200 and all that method. Okay, so you can calculate average speed very simply by this method as well. Okay, but you have to understand the intricacies of the method, that what the method requires in real terms. Okay, what is the method requiring in real terms? Okay, so this is how we do these kinds of questions. Let us move on to the next question. Okay, now see, we are going to see, our next topic is application of time, speed and distance in case of trains. Okay, our next topic is about application of time, speed and distance in case of train. So let us see. Okay, so the basic equation will be same, speed into time is equals to distance. Okay, Now see, we'll have two conditions when the train is crossing a moving average or train is crossing a stationary object. Okay, so we'll have some cases, we'll see them one by one. Okay, now see, the first case that we are seeing here is train is crossing a moving object. The speed has to be taken relative speed to the train with respect to the object. Okay, so obviously if the train and the object is moving in same direction, okay, so then your speed will be s1 minus s2 relative to which object is traveling, whether train is traveling faster or the object is traveling faster. And if train and object are moving in opposite direction, then you will write s1 plus s2. Okay, so the same concepts that we studied in relative speed, that will be applicable here. Okay, the same concept that we did in relative speed, that will be applicable here. Okay, fine. So now let us consider the distance to be covered when crossing an object. Whenever a train crosses an object will be equal to length of the train plus length of the object. Okay. So for example, if sometimes it is asked that what is the time taken by train to cross an object. Now, if the object has some length L1 or LO, let us say, and the train has length LT. So the distance traveled to cross the object is taken by LT plus LO. That is the length of the train plus length of the object. Okay, the length of the train plus length of the object. So whenever it is asked time taken by the train to cross the object. So now see, if the train is moving at a speed, let's say st, and the object is moving at let's say speed so, so the relative speed will be st minus so, depending upon whether the train speed is greater or not. Okay, so time taken will be given by what? Lt. Time taken to cross this object will be given by Lt plus LO, that is length of the train plus length of the object divided by speed of the train minus speed of the object. Okay, minus speed of the train minus speed of the object. Similarly, when train is traveling, let's say in this direction, and the object is traveling in opposite direction, so relative speed will be st plus so. So time taken to cross the object will be given by what? Lt plus so divided by st plus so. Okay, so see, this is the equation. What we are saying here basically, that if the train is crossing a moving object, so we will apply the same concept of relative speed. What? That whether if they are moving in opposite direction to each other, your relative speed is st plus so, that is the speed of the train plus speed of the object. Okay, and if they are moving in the same direction, then your relative speed will be st minus so, that is speed of the train minus speed of the object. Okay, now if it is asking, the question is asking how much time will the train take to cross the object. Okay, so if the object has some length LO, so we'll consider that. If the train has some length LT, we will consider that. So our distance that has to be covered for crossing the object is LO plus LT, and we'll take, if they are moving in same direction, so then our speed will be ST minus SO, and if they are moving in opposite direction, then our speed will be ST plus SO. So I hope everybody will be clear with this concept. Let us move forward to the next concept. Okay. So, okay. So, see, when that object is stationary, okay. So, for example, if there is a pole and somebody is asking, calculate the time the train will take to cross this pole. Okay. Now, pole doesn't have any length. Okay. Pole doesn't have any length. Pole has only height. We don't consider height. Okay. So, see what will happen here, because the length of the object we are taking as 0. Okay. And the pole is also related, matlab, pole is also at rest, so the speed of the object also will take at 0. Okay, so the time taken by train to cross a stationary object without length will be given by what? Length of the train divided by speed of the train. Okay, length of the train divided by speed of the train. Now if you want to if the train wants to cross a stationary object of length L, so that case LT plus SO divided by speed of the train, the time taken will be how much? LT plus SO divided by speed of the train. Okay. Now, if the train crosses a moving object without any length, okay. So the moving object doesn't have any length, but the moving object is moving in opposite direction. So LT divided by ST plus SO, and if the moving object is moving in the same direction, so time taken will be what? LT divided by ST minus SO. Okay, LT divided by ST minus SO. Now, if the train is crossing a moving object with length, okay, if the train is crossing a moving object with length, so that time LT plus LO will be given by ST plus SO. Okay, in opposite direction. See, we have already seen these concepts two times. Okay, so I hope now you will be able to do every questions related to train when it is crossing a stationary object without length, uh, uh, moving object without length, and a moving object with length. Okay, so we have covered all the cases all the cases very comprehensively here. Okay, so let us move on to the next question. Now we have this: a train crosses a pole in 8 seconds. If the length of the train is 200 meters, find the speed of the train. So now this is saying what? A train crosses a pole in 8 seconds. Okay, a train crosses a pole in 8 seconds. If the length of the train is 200 meter, find the speed of the train. Now length of the train is what? 200 meter. Okay, length of the train is 200 meter, find the speed of the train. So speed is equals to what? Now it is given, time is given, length of train and speed of the train is given. Okay, speed of the train is given. So from here you can obviously calculate. Time is given 8 seconds. Okay, length of the train is 200 meter. So the speed of the train is how much? Um, ST, okay, is equals to 200 divided by 8. Okay, so you will get this as what? You will get this as I think 25 meter per second it will come your answer. Okay, so obviously we have 4 2 times, we have 4 5s are 20 50 times, and we have 25 meter per second speed of the train. Okay, so this becomes so simple. Okay, this becomes so simple, you can calculate anything. Okay, let us look at this also. This will be a very simple question for us. It is saying a train crosses a man traveling in another train in the opposite direction in 8 seconds. Okay, the train crosses a man traveling in another train in opposite direction in 8 seconds. However, the train requires 25 seconds to cross the same man if the train is traveling in the same direction. Okay, if the length of the train, first train is 200 meter, and that of the train in which the man is sitting is 160 meter, find the speed of that first train. Okay, see here for us two conditions are given: the length of the train and the length of the object. So both are trains only and both are moving. Okay, so the length of the first train, okay, the length of the first train is given to be 200 meter. The length of the second train is given to be 160 meter. Okay, and they are crossing each other in opposite direction in 8 seconds. Okay, so that means speed of the first train plus speed of the second train, okay, is equals to this. Okay, 200 plus 160, so 360 is equals to the sum of speed of the first train plus sum of speed of second train. Sum of speed of the first train plus sum of the speed of the second train is equals to 360 by 8. Okay, now when they are moving in opposite direction, okay, when they are moving in opposite direction, they are taking 25 seconds to cross. So sum of the speed, sorry, a difference of the speed of the first and the second train, the length of the train will be 360 only. Okay, and you will have this as 25. Okay, you will have this as 25. So I think now everybody is very much clear. Obviously, just you have to calculate the speed of the first train, add this to equation. Okay, so you have 2 times of speed of first train is equals to 360 plus 8. Okay, and 360 plus 25. Okay, so your LCM becomes 25 into 8. Take 360 common, you have 25 plus 8 here. Okay, you have 25 plus 8 here. So you have 360 into 33 divided by 25 into 8. Okay, so what are you going to get here? Obviously, 490 times 4 2 times. Okay, 490 times 4 2 times 5 2 1 times 2 45 times, and here you will get 5 5 times and 5 9 times. Okay, so 9 into 33 divided by 5 you are getting. Okay, 9 into 33 divided by 5 you are getting. So you are getting this as what? 33 into 9 is, I think, 297. This is 27. This is 2. This is 297 divided by 5. 5 fives are 25, and then you have this as 47. 5 nines are 45. Okay, and then you have this 20, and then you have this 59.4. Okay, 59.4 meter per second. Okay, so this is the speed of the first train. 59.4 meter per second is the speed of the first train. Okay, so this is how you do these questions. Okay, so now let us move on. Let us move on to our next question. Okay. Um, Okay, so we have already seen. Now let us see about boats and streams problem. Okay, so see, boat and stream problem are also very similar to relative speed. Okay, see what is happening whenever you are having a boat. Okay, whenever you are having a boat, now when the boat is traveling upstream, okay, so it is traveling against the current because the current is downstream. Okay, when the boat is traveling upstream, so then when the current is opposing the flow of the boat, so then this speed of the stream will not assist the speed of the boat. It will create obstacle for the boat. So whenever the boat is moving upstream, you will subtract the speed of boat. uh, you will subtract the speed of the boat with the speed of the stream. So if your stream is flowing, let's say, at 3 meter per second, and your boat is going at 28 meter per second, so your net speed by which boat will move forward will be 25 meter per second. Okay, so and when the boat and speed are moving, sorry, when the boat and the speed are moving in same direction, that is the boat is moving downstream, so that means the flow is also downstream, the boat is also moving downstream. So in that condition, you are going to add the speed of the boat and speed of the stream. Okay, in that condition, you are going to add the speed of the boat and speed of the stream. So be very clear with this concept. And if in still water is there, so obviously you will consider the speed of the boat as SB only. Okay, fine. Now, see, this is very simple. Okay. Now, let us go for circular motion. Okay. In case of circular motion, what happens? Okay. Sometimes the questions are asked that when will one person overtake another person? Okay. When will they overtake at starting points, and all these kind of things are asked. Okay. Now, let us see what is the case of circular motion. Okay, so you have a circular track, okay, and the two bodies are moving in a circular track, and if they are moving in the same direction, okay, if they are moving in the same direction, so their relative speed will be taken by s1 minus s2. If one is moving at s1, another is moving in s2 speed, so their relative speed will be taken as s1 minus s2. Okay, now you, if you have a circular track and they are moving in opposite direction, okay, and they are moving in opposite direction, so their relative speed you will take at s1 plus s2. Okay, their relative speed you will take as s1 plus s2, okay, if they are moving in opposite direction. Fine. Now this concept is very much clear, but let us come to understand how can we calculate their meeting point. Okay, so for example, three or more bodies start moving on a circle. Okay, three or more bodies start moving in the circle simultaneously from the same point. Okay, so they are starting simultaneously from the same point on the circumference in the same direction. Okay, so they will first meet again in the LCM of the time that the fastest runner takes in totally overlapping each of the slower runner. Okay, so see, if we are having, let's say, x, y, and z. Okay, x, y, and z. Okay, fine. Now it is asking when will all of them meet. Okay, they are not asking when will two of them meet. When for two of them meeting, it is very simple. You equate the time, you know the speed, you can calculate it very easily. Okay, so when will three or more bodies will meet, if we have to find that, so what you have to actually find is that they will first meet again in the LCM of the times that fastest runner takes in totally overlapping each of the slower runner. Okay, so for example, this is let us say we have some person A, he is able to overlap each of these. Okay, so he is the fastest runner. Okay, and then we have x, y, z. Okay, x, y, and z. So if A is the fastest runner, and let us say that A takes 2 minutes to overlap x. Okay, and then we are saying that A takes 5 minutes to overlap y, and then we are saying that z takes 7 minutes to overlap z. Okay, sorry, A takes 7 minutes to overlap z. Okay, so we are considering four people here, A, x, y, and z, and we are saying that A takes 2 minutes to overlap x, A takes 5 minutes to overlap y, and A takes z minutes to overlap A takes 7 minutes to overlap z. Okay, so what I am saying here basically that the LCM of the time in which the fastest runner overlap each of the slower runners will give you the point at which they are meeting. Okay, or the time at which they are meeting. Okay, so at what point they are meeting? 2 into 5 into 7. So what is the time period? 10 into 7, that is 70 minutes. Okay, and obviously if you will calculate in 70 minutes, you can calculate one of them ki wo kahan tak sorry, you can calculate that by what distance that object has moved. If you calculate the distance, by what distance that object has moved, you will always be able to tell that where is the meeting point. Okay, so you have to calculate the time for the meeting point, and then you will be able to do any questions related to it. Okay, fine. Now, see, earlier we calculated that they are meeting anywhere on the circle. If we have to, let's say, find out where they meet first at starting point, when will they first meet at starting point? Okay, so now I am telling that sometimes, some or the other time, they are going to overlap each other at starting point by which they started. So, when will that time come? Okay, yeah, what is that time? Okay, so how we can calculate this thing? Okay, so the question is that three or more bodies are moving in the same direction. Okay, on the circumference of the circle, in the same direction around the circle. Now I am asking that at what time they will overlap at the starting point. So their first meeting point at the starting point will occur after a time that is got by the LCM of the times that each of the bodies takes to complete one round. Okay, the LCM of the time that each of the bodies takes to complete one round. See, this is very simple. Why? Because see, let us say that X takes 5 minutes to complete one round. Okay, Y takes 8 minutes to complete one round, and Z takes let's say 11 minutes to complete one round. Now, when will they meet at the starting point? Okay, so obviously the LCM, we have already seen this thing in LCM and HCF if you remember. Okay, so what is the LCM of 5, 8 and 11? The LCM of 5, 8 and 11 is 40 into 11, that is 440. Okay, that is 440. Okay, so 440 minutes. After 440 minutes, they will first overlap. Okay, so this is very simple. Okay, but do remember that when will they first meet at starting point? Okay, when will they first meet at starting point? That is, we will take the LCM of the time they will take to complete one round. Okay, the LCM of the time they will take to complete one round. And when will they first move? When will they first meet? At any point. Okay, so that will be the LCM of the times the fastest runner takes in totally overlapping each of the slower runner. Okay, so for that you have to find that when is the fastest runner overlapping each of the runners, and when you calculate that time when the fastest runner is overlapping each of the runners, and then you will take the LCM of that thing, then you will find that where they are meeting at first time. Okay, so this is how you do all these questions. Okay, so I hope you understood this concept. We'll do a lot of question on this, but let us first understand what are the basic concepts related to this time and distance. So now I think you are very much familiar with this circle concept also. Now let us see the concept of clocks as well. Okay, so now see, actually what is asked in the clock, it is sometime asking the angle between the two hands or these kind of things. So let us first understand how do we understand a clock, how a clock is moving. Okay, so for our numerical problems, what we do basically here, because the problems on the clocks are based on the movement of the minute hand and that of the hour hand, as well as on the relative movement between the two. So we will consider that a clock is a circular track and it is having a circumference of 60 kilometer. Okay, it is having a circumference of 60 kilometer. So what I am saying is, to consider, to solve the problems based on clock, I am assuming that clock is a circle with a circumference of 60 kilometer. Okay, that clock is a circle with a circumference of 60 kilometer, and each kilometer is being represented by 1 minute on the dial. Okay, see, we have 60 minutes now, so each kilometer is represented by 1 minute on the dial. Okay, each kilometer is represented by 1 minute on the dial. Okay, and how many hours you have? You have 12 hours, because in a clock you don't have 24 hours, right? You have only 12 hours. Okay, so each hour is represented by how many kilometer? 5 kilometer. Okay, each hour is represented by 5 kilometer. Okay, why? Because you know you will have 5 division of minutes before you are reaching the next. Okay, so or 60 by 12 is equals to 5. Okay, so we are considering that circumference is 60 kilometer. Okay, so each hour is represented by how many kilometer? 5 kilometer. Okay, 5 kilometer. So see, now when we know that each minute denotes 1 kilometer and each hour denotes 5 kilometer. Okay, each minute denotes 1 kilometer and each hour denotes 5 kilometer. So now we can see the minute hand. Okay, minute hand is a runner. Okay, minute hand is a runner. That is, my circles are very bad, I am very sorry. Okay, so I am considering the minute hand as a runner who is able to run at the speed of 60 kilometer per hour. Okay, who is able to run at the speed of 60 kilometer per hour, and I can see the hour hand as a runner who is able to run at 5 kilometer per hour. Okay, I can consider the sorry, hour hand as a runner who is able to run at 5 kilometer per hour. Okay, this is all the assumption I am making. Why? Because I want to solve my question. So what is the first assumption I made? I made first assumption that the clock is a circle of circumference 60 kilometer. Okay, and each minute denotes 1 kilometer. Okay, and each hour denotes 5 kilometer. Why? Because we have 12 hours and 60 divided by 12 is 5. Okay, so each hour denotes 5 kilometer. So this is very fine for me. Now I am saying what? We can look the minute hand as a runner running at the speed of 60 kilometer per hour. Okay, so we can consider this as it is running at the speed of 60 kilometer per hour, and we can also look at the our hand as a runner running at the speed of 5 kilometer per hour. Okay, 5 kilometer per hour. So this is how we do these kind of questions. Now see, now we already know that minute hand is running at 60 kilometer per hour, and our hand is running at 5 kilometer per hour, per hour. Okay, so minute hand is running at 60 kilometer per hour, and our hand is running at 5 kilometer per hour. Okay, our hand is running at 5 kilometer per hour. Fine. Now with every hour elapsed, the minute hand goes by 55 kilometer. So now, see, always the minute hand and hour hand will be in the moving in the same direction. Okay, you will never find that minute hand and hour hand are moving in opposite direction. Okay, this never happens. The minute hand and hour hand are always moving in the same direction. So when they both are moving in the same direction, their relative speed can be given by how much? Relative speed of the minute hand minus relative speed of the hour hand. And what is the speed of the minute hand? 60 kilometer per hour. And what is the speed of hour hand? 5 kilometer per hour. So you get 55 kilometer per hour. Okay, so the relative speed between the minute hand and hour hand is always 55 kilometer per hour. Okay, so this is basically the concept we are having. Okay, the concept is what? Assuming that clock is a circle of circumference 60 kilometer per hour, and each minute represents 1 kilometer, each hour represents 5 kilometer. The speed of the minute hand is 60 kilometer per hour, the speed of the hour hand is 5 kilometer per hour, and the relative speed is 55 kilometer per hour. Okay, so this is all that we are considering. Now let us see something about right angles. Okay, see, right angles are formed when the distance between the minute hand and hour hand is 15 minutes. Okay, uh, what I'm saying here is a right angle is formed when the distance between the minute hand and the hour hand is 15 minutes. Okay, so see, whenever 15 minute means, for example, your hour hand is at 12, so your minute hand is at that is 1, 2, and 3. Okay, your minute hand is at 3. Okay, so and if your hour hand is, let's say, at 1, then your minute hand is at 4. Okay, so in every 15 minute or whenever the distance between the minute hand and the hour hand is equal to 15 minutes, you will have a right angle. Okay, you will have a right angle. Okay, and when you will have a straight line, you will have a straight line in every hour. Okay, you will have a straight line in every hour twice. See, the straight line will be um, when both are in a similar position. Okay, when the minute hand and hour hand coincide, so then you will have a straight line. Okay, and when the minute hand and hour hand are opposite to each other, then also you will have a straight line. Okay, then also you will have a straight line. Okay, so in every hour we will get two times a straight line. Okay, now the one thing is that see what will happen, because how many hours are there? 24 hours are there. So we will consider that two straight lines per hour, so we will have 48 straight lines. Okay, we'll have 48 times the straight line is made on the clock. Okay, in 24 hours. Okay, but uh, look at this thing. Let us make a clock. Okay, so I don't know why I'm not able to draw very good circle whenever I draw with pen tab, but okay, try to adjust with it. Okay, so we have here, we'll have 12, we will have 1, we'll have 2 here, we'll have 3 here, we'll have 4 here, 5 here, 6 here, 7 here, 8 here, 9 here, 10 here, and 11 here. Okay, this is our clock. Okay, now it is saying the second straight line between 5 and 6. Okay, the second straight line between 5 and 6. Now see, one straight line will be when one straight line you will have when let us say our hand is somewhere here and minute hand is also somewhere here. The second straight line you will have when the hour hand is here and the minute hand is somewhere here. Okay, and uh, it is saying the second straight line between 5 and 6 and the first straight line between 6 and 7 coincide. Okay, and the first straight line between 6 and 7 will coincide with each other. Okay, or uh, the second straight line between 11 and 12. Okay, so between 11 and 12, first you will have what, a straight line like this, and then you will have a straight line like this. So see, this 11 and 12 is straight line, and 5 and 6 is straight line are coinciding. Okay, so this 5 and 6 straight line will be like this, and this 11 and 12 straight line will be like this. So this is exactly the same straight line. Okay, and similarly the first straight line between 6 or 7, okay, the first straight line, let us say, will be this way. Okay, and this way, and the straight line between this 12 and 1, that will also coincide. Okay, so we will not have these straight line. Okay, so we will not have 48 straight line. Fine. So because this straight line and this straight line is coinciding, and this straight line and this straight line is coinciding with each other and are represented by a straight line formed at 6 or 12. Okay, so we will have only 46 straight lines. Okay, we'll have only 46 straight lines, we will not have 48 straight lines. Okay, fine. Now see, we already knew that whenever there is 15-minute distance between the hour hand and the minute hand, then we get a right angle. Now what about the number of right angles? Okay, so we are saying that between any two hours, that is, let us consider between 12 and 1, will have two right angles. Okay, so for example, we'll have two right angles between 12 and 1, with right angles between 1 and 2, two right angles between 2 and 3, and 3 and 4, and so on. Okay, so that means we'll expect that in a day 48 right angles will be having, but that is not the case. This happens because, see, whenever the clock passes between the time period 2 and 4, or between the time period 8 and 10, there are not 4 but only 3 right angles. Okay, there are not 4 but only 3 right angles. Try to make those right angles, and you will see that those right angles will coincide. And this happens why? Because the second right angle between 2 and 3 and the first right angle between 3 and 4 are one and the same, occurring at 3 or 9. Okay, so the second right angle between 2 or 3 or 8 and 9, and the first right angle between 3 or 4 and 9 and 10 are the one and the same. Okay, so let us consider this. So we are saying similarly in the case of right angles, okay, you will find that some of the right angles coincide. Okay, you will find that some of the right angles coincide. Which right angles coincide? The whenever the clock passes between the period from 2 to 4, or between the period from 8 to 8, 8 to 10, there are not 4 but only 3 right angles. Okay, and why is this happening? Because between 2 to 4 and 3 to 4, okay, the second right angle between 2 to 3 and the first right angle between 3 and 4 coincide. Okay, the second right angle between 2 and 3 and the first right angle between 3 and 4 coincide. And then we are saying the first right angle between 8 and 9, or 9 and 10 are coinciding. So because between 2 to 4, or between the period 8 to 10, there are not 4 but only 3 right angles. Okay, so we have 2 right angles less. Okay, so when we have 2 right angles less, we are left with only 46 right angles. Okay, you can draw this and you can see it will be very much evident to you about these right angles. You will draw and see, it will take a lot of time. Okay, it will take a lot of time. So let us go to the question first. Okay, now see, obviously, straight lines are formed when the distance between the minute hand and the hour hand is equal to either 0 or 30 minutes. Okay, and 90-degree angle is formed whenever the distance between the hour hand and the minute hand is 15 minutes. Okay, it is 15 minutes. Fine. So this now we already know. Now look at this question. At what time between 2 to 3 p.m. is the first right angle in that time formed by the hands of the clock? Okay, so between 2 to 3 p.m., Okay, between 2 to 3 p.m., we have to find the first right angle. Okay, we have to find the first right angle. Now, how are we going to find this right angle? Okay, so let us do this question. Okay, let us find the first right angle. See, now what we have to do, see, to find the question is saying at what time between 2 to 3 p.m. is the first right angle in that time formed. Okay, so basically, whenever the clock hits 2 p.m., okay, so we can see that at 2 p.m. the hour hand has moved 10 kilometers behind. Okay, the hour hand has moved 10 kilometer from 12. Okay, and now, what is this exactly? Okay, let us consider this by drawing our diagram. Okay, so uh, fine. So whenever the clock will first hit 2 p.m. Okay, the clock will first 2 p.m. So your hour hand is here. Okay, now see your hour hand will move. Your hour hand will move a little when your minute hand will move. Okay, when your minute hand will move, your hour hand will also move. Okay, so we have to calculate those things. Okay, at what time? Fine. Now at 2 p.m. the minute hand can be visualized being 10 kilometer behind the hour hand. Okay, so this is very evident that whenever it is 2 p.m., okay, whenever it is 2 p.m., so your minute hand is uh, 10 10 minutes behind your uh, uh, hour hand. Okay, this is the minute hand at 2 p.m. and this is the hour hand at 2 p.m. So at 2 p.m. the minute hand, okay, the minute hand is 10 minutes behind the hour hand at 2 p.m. Okay, now see, the first right angle between 2 and 3 will be formed when the minute hand is 15 kilometer ahead of the hour hand. Okay, the first right angle between 2 and 3 will be formed. Okay, the first right angle the first right angle between 2 and 3 will be formed when the minute hand is 15 minute ahead of this hour hand. Okay, so at when the clock hits 2 p.m., so now from here this has to travel 25 minutes. Okay, this has to travel how many minutes? 25 minutes. Okay, or 25 kilometer as we say, because we are considering that the entire circumference is 60 kilometer. Now we are considering that it was that minute hand is 10 kilometer behind the hour hand. Okay, at exactly 2 p.m. and to make the first right angle, the minute hand has to travel 15 kilometer. Okay, 15 kilometer. Now see, in this case, we will have to use the relative speed of hour and minute hand. Okay, we cannot consider the speed of only minute hand because your hour hand is also moving. Okay, so we already know the relative speed is 55 kilometer in 1 hour. Okay, that means 1 kilometer is traveled in 1 by 55 hour. Okay, 1 kilometer is traveled is in 1 by 55 hour. Okay, so 25 kilometer has to be traveled, so that will be done in 25 by 55 hour, 25 by 55 hour, and this is nothing but 5 by 11 hour. Okay, this is nothing but 5 by 11 hour. Now it is asking at what time is the first right angle in that time formed by the hands of the clock. Okay, so the 5 by 11 of an hour. Okay, so the first right angle will be formed between 2 and 3 is formed at 5 by 11 of the hours past 2 o'clock. Okay, now we have to convert this 5 by 11 into minutes. Okay, into minutes. Okay, so see, we already know 1 hour is equals to 60 minutes. Okay, we already know that 1 hour is equals to 60 minutes. So 5 by 11 hour will be equal to how many minutes? Okay, so 5 by 11 hour is equals to 5 into 60 by 11 minutes. Okay, so that will be 300 by 11 minutes. Okay, so let us just solve this. Okay, let us just solve this. See, We got this 5 by 11 hour. Okay, now we got 1 hour is equals to 60 minute. Okay, so 5 by 11 hour is equals to 300 divided by 11 minute. Okay, because 5 into 60 है ना, 5 by 11 into 60 is equals to 300 by 11 minute. Just divide this. Okay, so when you will divide this 300 by 11, what we are going to get, you will get 2 here. Okay, you'll get 2 here, so 22 here, and then we'll get 88 here. Okay, we'll get 88 here. Fine. So sorry, 80 here. So now you will have 7 here, you will have 77 here, you will have 3 here, you will have 0 here, you will have 2 here, you will have 22 here. Okay, so this way it will continue. So basically we are getting what, we are getting 300, we are getting this 11 here, so we are getting this 22 here. Okay, we are getting this 80 here, we are getting this 7 here, we are getting this 77 here. So you have this 27 3 by 11. Okay, 27 3 by 11. Fine, 27 3 by 11 minutes. Okay, so obviously you know you got 27 minute. Now we have to find what is this 3 by 11. Okay, what is this 3 by 11? So 1 minute is equals to 60 seconds. So 3 by 11 minute is equals to how many seconds? Okay, 3 by 11 minute is equals to how many seconds? Fine. So 3 by 11 minutes is equals to 3 into 60 by 11 seconds. Okay, 3 by 11 minutes is equals to 60 into 3 by 11 seconds. So basically, you will get 180 by 11. Okay, 180 by 11. Just divide this. Okay, just divide this. So you have this 180 by 11. You will get 1 time. This will be 70. You will get this 6 6. You will get this 40. Okay, so you will get the just you will have this 33 again. Okay, then you will have this 70. Okay, then you will have this 6 again. So 16.3636 I think will recur. Okay, so you will have your first right angle at 27 minute and 16.3636 second. Okay, so if we want to calculate the exact time here, so that will be 2 hour 27 minute and 16 seconds. Okay, 2 hour 27 minutes and 16 seconds. See, whenever you have to calculate the right angle, when is the right angle occurring, so you have to do in this way only. Why you have to do in this way? See, because see what is happening here is both the hands are moving. Your hour hand is also moving, your minute hand is also moving. Okay, your hour hand is also moving, your minute hand is also moving. That is why we are doing this thing. Okay, so let us consider again what we did here. See, we said that at 2 o'clock, exact 2 o'clock when it was there, your minute hand was 10 kilometer behind what? 10 kilometer behind your hour hand. Okay, to make the right angle, your minute hand has to move 15 kilometer past. So overall, this has to cover a distance of 25 kilometer. Okay, 25 kilometer. But your hour hand is also moving in the same direction. So to relatively cover 25 kilometer, we will use relative speed. So we know relative speed of a minute hand with respect to our hand is 55 kilometer per hour. Okay, 55 kilometer per hour. So the right angle will be at 25 by 55. So that means 5 by 11 of an hour. Okay, and what is 5 by 11 of an hour? 1 hour is equals to 60 minutes. So 5 by 11 of an hour is equals to 300 by 11. That is 27.3 by 11 minute, and 3 by 11 minute, 1 minute is equals to 60 seconds. So 3 by 11 minute is equals to 180 by 11 seconds. So that will be 16.3636 it will come. Okay, so that becomes 2 hour 27 minutes and 16.36 seconds. Okay, so this is how we do this. Okay, this is how we do these kinds of question. I think all of you must be clear with these things very well. And now we can end this class. Okay, we can end this class. I hope everybody must be clear with this thing.